Currently, Goa faces two major problems in the power sector. First is the peak load shortage, second is absence of two-way communication. Solving these problems is not only a necessity, but it is also for a better future. Our project can definitely solve these issues by meeting the following objectives. In order to control these loads in a smart fashion, we have designed a mobile application so you can control these loads through these buttons on the phone. It also shows you your current power consumption in form of digits as well as the graph and also the tariff rate at the moment. You can also use Google Assistant to control these devices through voice. Turn on outdoor lights.
Okay, switching on outdoor lights.
Turn off outdoor lights.
Okay, switching off outdoor lights.
The microcontroller takes in data from sensors and calculates the power. Now these power details are sent on to a server via the internet and they can be represented onto this website. Now this website mimics our utility. Here you can see the power consumption details getting updated. And this data can be extracted in form of an Excel sheet. Now here you can see the time and the power consumption beside it. This can be used to calculate the consumer bill in a remote manner. Considering this time of use curve, if you were to use your washing machine in this time slot, you would not only incur expensive bill, but you would also stress the utility at peak hours. Now to solve this, you can shift this washing machine to another period where it is less expensive. So if I turn on my washing machine in a peak period, I would get a notification stating to shift it. To shift, I can press the shift button or use Google Assistant. Shift washing machine.
Okay, washing machine has been shifted.
During power shortages, the user is invited to participate in DR event. Upon acceptance, he has to maintain the power consumption below a certain limit. To limit the power consumption, the algorithm turns off a set of loads such that they provide least discomfort to the consumer as well as adequate power reduction to the utility. This is a residential load curve. The demand response algorithm was tested upon this peak period. If we zoom in the peak period, this is the curve without any reduction. Now upon 5% reduction, this is what we get. Similarly, with 15% reduction, we can see that the yellow curve is lower than the red curve. Finally, for 30% reduction, we can see an extensive reduction in power. Overall, the power is reduced in steps. And this is very beneficial for us as it has no abrupt power changes. Assuming that the project is incorporated for 10,000 houses, each house would be able to save 16 to 25 rupees per day. Then for 10,000 houses, it would be 1,60,000 to 2,50,000 rupees per day. Now for demand response operation, each house could curtail an energy of 0.6 to 2.1 units for each demand response period. Hence, for 10,000 houses, the net energy curtailment value would be 6 MWh to 21 MWh. The results obtained are significant numbers which can definitely put a net positive impact on our power system and most importantly also on our environment. For further details, you may contact here.